Welcome to my channel. In this session I am going to explain you about Huffman coding to solve the problem through Huffman coding. So before going into the problem, let me discuss about the things or points to remember, that is formulas to be remembered and the steps to be carried. So we need to find first the average number of bits per message, which is represented in terms of I bar here. So I am noting here as I bar. So in books they might have represented in terms of L bar or N bar. Don't get confused, it is all same. So I bar is equal to summation I is equal to I ranging from 1 to N for Pi into Li, length of the symbol. Then entropy H or H of S, which is given by the formula H is equal to or H of S is equal to summation I is equal to 1 to N Pi into logarithmic value base 2 of 1 by Pi. Next is efficiency. Efficiency is calculated from the formula of H divided by I bar. That is, you have calculated entropy and average length of that is average number of bits. You need to subtract here in order to find efficiency. It is given by H of S divided by I bar or L bar or H divided by I. And code redundancy is nothing but it is represented in terms of gamma symbol, that is 1 minus efficiency term. So the other point you should remember here is efficiency. You will get the answer always which is greater than or equal to 90%. You will get always 90% above. Then your answer is perfectly right. Else you need to check with the answers. Next is regarding code redundancy. You can check, verify it. You need to subtract the value before converting into 100%. So you will get a minimal value of some 0.01, etc. So now we will go into the problem. So this is the problem question. So 5 source messages are probable to appear as M1 is equal to 0.04, M2 is equal to 0.15, M3 0.15, M4 0.15 and M5 as 0.15. Find the coding efficiency and redundancy for Huffman coding and Shannon-Fano coding. First let me explain you about Huffman coding alone. For the same problem we will work out for Shannon-Fano coding. So given problem we have analyzed that there are 4 messages. So step 1 is you write what are the messages and probabilities. Messages and probabilities. Probable to appear means it is probability. So here message is given by M1, M2, M3, M4, M5. Here sequences they have given the symbol representation themselves. Sometimes they will not represent specifically M1, M2, M3 etc. They will just give the probability alone. In that case you can take any of the variables here. So here the first one is 0.4, 0.15, 0.15, 0.15 and 0.15. So here we need to check whether it is in the descending order. Step 1 is to find whether the given probability is in descending order. Descending order means from larger value to smaller value. So here this is the largest value. So 0.15 it is same. It is all appearing next to 0.14. So we need not rearrange in the formats. Whatever format is given we can take it as such. So what is step 2 is, so there is no need to arrange in the descending order. So directly we are going into the problem here. So for that step 2 you need to follow these steps, that is you write this symbol or message. So here they have given here as message. So draw this for method for all the problems. It will be very neat. Probability. Then you could go with step 1, the stage 1, stage 2, stage 3 and stage 4. So you could see here, if the number of message bits here is 5, probability case is 5, so you can analyze here, it will appear for till this much stage. So here I could say it will appear till this 4th stage, n minus 1 stage. Next is number of code, that is code word. So what are the code word we are going to get? Now next is about the code length. So this is how you should specify a neat tabular column for your given problem. So here, since the message symbol you need not rearrange, write it as such: M1, M2, M3, M4, M5. Then their corresponding probability 0.14, 0.15, 0.15 and 0.15. So here this is the case. So for the first case, you should check the last two bits, whatever it is arranged, should be added together, and you should check the value and place it in the descending order again. So if you add these two values, how much you will get? It is 0.3. 0.15 plus 0.15 is 0.3. So you should check in the order which it appears. So checking this, it gets 0.13. So 0.3 is less than 0.4. So you should place this 0.4 in the first stage itself, whereas 0.3 is greater than 0.15. So this added value should be placed in the second position. So the value is 0.3. And here this 0.15 is present. So you should shift this 0.15 to the next level. 0.15. Then remaining here is again one more 0.5. You should shift to this next location of 0.15. So this is how it gets shifted, and one bit value gets reduced. So finally we will get a stage till stage 4. We will get reduced of this reduced bits. So again the same procedure should be repeated. So 0.13 plus 0.13 is again 0.3. So 0.3 is not greater than 0.4. So 0.4 as such is shifted here, and this 0.3 here is also we are getting 0.3. So whatever we are adding, that should be placed next to the value whatever it is. So if the value is same, if it is same, you should place only the value what you get added now to the topmost position and shift this to the next level. So 0.3 should be placed here, whereas this gets shifted to the next position of 0.3. So again adding these two, you will get 0.6. So these two adding, you get 0.6. This 0.6 is greater than 0.4. So it should be placed in the topmost level. So this is 0.6, whereas this gets shifted to the next position of 0.4. So you cannot club together and you cannot add together, which cannot be placed in the next stage. So you can stop with this stage, so where only the symbols to be represented is noted. So here whatever this division here is, for the top for the bottom level you should assign the bit as 1, whereas dividing the bits, right, dividing these two bits, for the below level you should represent it as 1, whereas for the top level you should represent it as 0. Assign it as 0. So the next stage is to find the value from the bits whatever we are obtained, that is tracking whatever the bit is being received. So first you should find out for the value of 0.4, that is probability value 0.4 from the reverse process. Actually the process is to be done from the transmitter to the receiver, but since it is difficult for us to find whatever the transmitted symbol is obtained in the receiver, we are tracking from the back and we are taking it as a mirror image. So here taking the value of 0.4, you could see how it is tracked. So 0.4, the value gets tracked in this way. So it is received, it is obtained from this way. So it has a value of this, then it is tracking towards this, then it is so it is received from value in this direction. So how many if it is lowered, it is coming down, the value is 1. If it is moving up, the value is 0. So here the tracking the bit of 0.4, we get only 1 as output. So here only 1 bit is achieved as output, that is 1. Next, going for 0.15, that is M2 message bit 0.15. So tracking this 0.15, here this is the bit, it goes here, then it goes, so first bit achieved here is 0, next it is going up, it is also 0, then again it is going up, so it is 0. So the mirror image of this is 0, 0, 0. The mirror image of 1 is actually 1. And coming for 0.15, it is also achieved in the same way. It is coming down, right? So coming down here, we have the value of 1 here, not 0. So here the value is 1. Again it goes up. So it going up, it goes to 0, right? 0, then it going up. So it is 0, then it is tracked to 0. So the mirror image is 0, 0, 1, the reverse side. Next is for this bit M4. M4, it is starting from here, it is 0, going upwards, and it is reaching down. You should check only the point where it reaches as the output. So here it is 0, right, going up, then it is coming down, so it is 0, coming down 1, and again going up, so it is 0. So it is 0, 1, 0. Next is last bit, it is tracked as 1 actually. 1 is again going up, it is received down, so the value here is 1 again, so it is 1, 1, then it is again going up, so 1, 1, 0, the mirror image is 0, 1, 1. So you could see, hope you have understood. So how it is achieved is by means of tracking the arrow marks, you can write the value of this code word. So writing this code word is very, very important, and tracking the bit is also very, very important. And assigning them 0 and 1s is based on the movement of this bit towards up position or in the down position, right? So here the number of code, that is code length, is nothing but the number of code word bits. So here only 1 is present, so 1 bit. Here 3 bits are present, so here 3, then this 3. What about here? Here also 3, here also 3 bits, here also 3 bits. So this is how you have calculated your code length. So this tabulation is very important in finding the results. So next we will proceed with the steps what we have explained with the points to remember case. So coming to the step 3, we need to find out, first one we need to find L bar, next we need to find entropy, then we can go with efficiency, and finally redundancy. So finding out L bar or I bar. So here I bar or L bar is nothing but I am taking it as I bar here. I bar is equal to summation I is equal to 1 to n pi suffix li. So what is this? The L is nothing but this is your code word length, and what is your probability is nothing but here it is your probability. So it's given by suffix pi because this I represents how many number of message symbols you are transmitting. So here how many symbols are taken? 5 symbols. So the formula it now gets shortlisted as 1 to 5. So 5 symbols are transmitted, so it is pi given li. So summation means it tells you addition of the symbols ranging from first symbol to fifth symbol. So it is nothing but elaborating it, substitute p1 l1, p2 l2, p3 l3, p4 l4 plus p5 l5. So probability here is 0.4 for the first case. What is your length of the first symbol is 1. Next is 0.15. Length of the next symbol is 3. It gets repeated. 0.15. The length of the next symbol is 3. And here length of the next symbol is also 3. for 0.15, the length of the next symbol is also 0.15 into 3. So the very important thing is you should bring your calculator for your respective exams. Without calculator you can't proceed this sum. So here this is 0.14. So you could see here 0.4 plus 0.15 into 3. Let me calculate once again. 0.15 into 3 is equal to 0.45. Actually we have 3 symbols in extra, so 0.15 into 3 is equal to 1.45 plus 0.4. the answer is 1.75. sorry, could calculate 0.15 into 3 is equal to 0.45 into 4 times. So 4 times it is 1.8. 1.8 plus this value of 1.4, so plus 0.4. The answer is 2.2. So what is your I bar is 2.2 bits per message. Step 4 is calculating the value of entropy in terms of h of s or h. I am taking it as h of s here. The formula for this is summation I is equal to 1 ranging to n pi logarithmic value of base 2 1 by pi. So this is tedious to calculate in calculator using for base 2. So we need to convert this into the form which is easier for us to calculate using calculator. So we need to change here pi. This log value becomes base 10 of 1 by pi divided by log value of 2 to the base 10. So this is how you need to calculate for your entropy. So when you calculate entropy, remember this formula is to be used for calculation. For representation, though, you go for this term for base 2. So using calculator you can proceed and get the correct answer only if you use this formula. So coming to our formula, there is problem. H of s is nothing but summation I is ranging from 1 to the number of symbols here is 5. So the same formula, log value base 10 of 1 by pi divided by log 10 of 2. So I will go step by step. So coming with h of s. So here the probability, the first case, the probability here is, the given probability here is 0.4, right? So this is probability of first one is 0.4 into log base 10 of 1 by 0.4 divided by log 10 base 2, right? Then next probability is 0.15 log base 10 of 1 by 0.15 divided by log 10 base 2 plus again the three terms gets repeated. So log 10 of 1 by 0.15 divided by log 10 base 2. So write these formulas step by step. Now using the calculator, I'll show you how to calculate this. So this is 0.4. So press 0.4. Open the braces. So first, go with log value first. So log of, open the braces, 1 divided by 0.4 divide by 1 divided by 0.4 divided by 0.4 equal to log value divide by log 2 into the value here is 0.4. So you get the answer of 0.52877. Go with value after decimals. There is 4 places after decimals. Plus you can calculate this value only once and you can multiply this 4 times. So this is one simple step. So you could go with 1 divided by 0.5, or you can go with log of, open the bracket, 1 divided by 0.15, close the bracket, equal to divided by log 2. What is the value here is 2.736 into the value here is 0.15 again. So you get the value of 0.4105. So this is repeated for 3 values, 1 plus 2 plus 3 values. So you just multiply this with 1, 2, 3, 4 times. So 4. You will get the answer as 1.6421. Here the value is 52877. Just add this value. Add this value of 0.52877. You will get the answer as 2.1709. 4. So after 9 it is 4. You can just leave this value as 4 itself. So we have achieved the value of h of s as 2.1709. Now our next step is to calculate using the formula and finding. Step 5 is finding efficiency. What is efficiency formula? Efficiency is given by h of s divided by I bar or L bar. So here it is 2.1709. What is your I is nothing but 2.2. So just divide this by 2.2. You will get 0.9867. So if it is in percentage, so percentage efficiency, so multiply this with 100. So it will get 98.67 percentage. So finding out step 6 is your code redundancy, which is given by 1 minus the efficiency value. So you will get 1 minus 0.9867. So the formula, that is 1 minus 1 is nothing but it is 0.0132. So the answer is 0.0132. So this is your code redundancy. So we have calculated what is our entropy, what is our efficiency, and what is our redundancy. And you could check this value is equal when you are proceeding the same problem with Shannon-Fano coding also. Hope you understood this problem. Let me explain the flow once again. So you know, if the probability is given along with some messages, arrange the probability in descending order. In some problem they will be directly giving the values. So here they have directly given the problem in the descending order itself. There is no need for rearrangement. So here step 2, you need to rearrange the symbols. After rearranging the symbols, if it is required, you go with the stage separation and write the code word and code length. This is the basic tabulation you should follow. So writing the messages and messages in descending order, probability in descending order. First follow which last 2 bits to be added. Last 2 bits addition value, which compare with the value of the highest value. If the rule here is to place the largest value in the topmost level, and they arrange the smaller value next by next. Okay, so here 0.3 is less than 0.4, so I am placing it here. Again comparing these two, I am getting 0.3. Since these two values are same, though these two values are same, we will place only the value obtained after adding in the topmost position. So place this 0.3 here and shift this 0.3 over here. So in this way you proceed till this stage, and always assign 0 for the top level and 1 for the bottom level bits. So for tracking, you should track from this side, that is 0.4. First we need to find out what is the probability case for 0.4, the code length whatever it is. So 0.4 it is going in this direction, so it has only one shift 0.4 which is having towards down, and the value of down value is 1. So so that only I am giving it as 1 here. Next is 0.15. So 0.15 it is shifted down. Again you should check with this symbol. So though it is coming down, the value here is 0 because it is next level it is going up. So it takes the value of 0 since it is going up. So after this route it again goes with 0, again it goes with 0. So the value here is 0, 0, 0. And say here also 0.15 it is coming down. There is no value for 0, so it is taking the value of 1. Again it is going up. So here the value here is 0. Again it is going up, so it is 0. So you should track the value in such a way it traces the bits level present in the position only. So it will be little bit confusing when you take these values. So track the value how it moves to the next level. So in that way you can correctly write the code word. So this is how you write the code word and obtain the code length by counting the number of bits present. So remaining here is the formula substitution only, calculation of I bar and calculation of entropy and calculation of efficiency and redundancy. The important step you need to identify here is when calculating entropy you should go for the formula only this, that is summation I is ranging from 1 to n pi logarithmic value of base 10 of 1 by pi by log 2. You shouldn't go directly with this value, you will get a wrong answer. Avoid this. And always the efficiency value will be in terms of 90% above. So here we have achieved 98.67 and here also 0.1 value will be obtained as code redundancy. All the very best for your exams. Thank you.